In this topic, let us try to observe the concept of symmetry of curves. So in the function y is equal to f of x, if you put minus x in the place of x, if the curve does not change, that means the curve is symmetric about y-axis. So I'll give you 4 standard results, then I'll try to explain them. So put minus x in the place of x. If the curve does not change, then the curve is symmetric about y-axis. Put minus y in the place of y. If the curve does not change, then the curve is symmetric about x-axis. Put minus x and minus y in the place of x and y respectively. If you replace x with minus x and y with minus y, if the curve does not change. Put minus x and minus y in the place of x and y respectively. If the curve does not change, then the curve is symmetric in opposite quadrants. That is, the curve is symmetric about origin. Put x in the place of y and y in the place of x. Interchange x with y and y with x. If the curve does not change, then the curve is symmetric about the line y is equal to x. So these are 4 very simple symmetry rules that you can check in different curves, which makes drawing of curves very easy in some situations. For example, let us look at these 4 curves. The first curve, y is equal to e power x square. So in this curve, as you can see, if you put minus x in the place of x, so the curve becomes y is equal to e power minus x whole square. But what is minus x whole square? Minus x whole square is same as x square. So y is equal to e power x square in this curve. If you put minus x in the place of x, the curve is not changing. That means this curve is symmetric about y-axis. That means if you try to draw the graph of this, so if you draw the graph in one half of x-axis, the other half can be symmetrically filled. For example, if you want to draw the graph on this side of x-axis, corresponding to x is equal to 0, y is equal to 1. Corresponding to x is equal to infinity. That is, if x is a very large number, x square is a very large number. That means as x square increases, e power x square increases. So that means as x increases, the value of e power x square is increasing. So this is how the graph of e power x square looks on the positive side of x-axis. And we have already seen that the graph is symmetric about y-axis. Hence, this part of the graph can be filled easily. So this will be the shape of the graph of e power x square. So now there are some questions that are remaining. So one of the questions that is remaining still now is whether you have a sharp edge here or a smooth curve here. Sharp edge or a smooth curve. That fact can be concluded using the topic of maxima and minima or differentiation. We'll look into it later. So right now we are looking at the symmetry. So y square is equal to 4x. Y square is equal to 4x. So if you put minus y in the place of y, minus y whole square is same as y square. So y square is equal to 4x. So if you put minus y in the place of y, the curve is not changing. That means the curve is symmetric about x-axis. Curve is symmetric about x-axis. So if you draw the curve on one side of x-axis, the other side can be filled out. So y square is equal to 4x. So effectively y is equal to 2 root x plus or minus. So 2 root x graph can be filled very easily. This is a square root function. If you multiply it with 2, the shape doesn't really change. shape does not change. So y is equal to 2 root x is this. Now this graph is symmetric about x-axis. So you can fill the graph like this. So this is the graph of y square is equal to 4x. So let us take this graph. X square plus y square by 3 is equal to 1. So in this case, put minus x in the place of x, the curve does not change. So it's symmetric about y-axis. Put minus y in the place of y, then also the curve does not change. Symmetric about x-axis, right? So the graph is symmetric about x-axis and also y-axis. And put minus x in the place of x and minus y in the place of y simultaneously. Minus x in the place of x, minus y in the place of y simultaneously. The curve does not change, hence it is symmetric about origin also. And put y in the place of x, x in the place of y. So instead of x you put y. So y square plus x square by 3 is equal to 1. Put y in the place of x, x in the place of y. You can see that the curve is changing. This curve is different from this curve. Hence, this curve is not symmetric about the line y is equal to x. So if you draw the curve, we know that it is an ellipse. The denominator of y square is more than the denominator of x square. So it is a vertical ellipse. You can clearly see that this is symmetric about x-axis, y-axis and about origin also. And it is not symmetric about the line y is equal to x. You can see this very clearly. If you fold this, get some curve like this. If you fold this, this goes here. So you are not able to exactly fold the curve about the line y is equal to x. And why is this happening? Because if you put y in the place of x, x in the place of y, the curve is changing. Next, if you go here, xy is equal to 5. Put minus x in the place of x. You get minus xy is equal to 5. Curve has changed. So it is not symmetric about y-axis. Not symmetric about y-axis. Put minus y in the place of y. Here also you get minus xy is equal to 5. The curve has changed. So not symmetric about x-axis. Put both these transformations simultaneously. Put minus x in the place of x and minus y in the place of y. You can see that the curve is not changing. It means the curve is symmetric in opposite quadrants, or the curve is symmetric about origin. And put y in the place of x, x in the place of y. You get yx is equal to 5, which is the same curve. That means the curve is symmetric about origin and y is equal to x. So if you draw the curve, we know that the curve looks something like this. You can clearly see that the curve is symmetric about origin. And also the curve is symmetric about the line y is equal to x. So if you fold this curve will exactly overlap on this part will exactly overlap on this part. So I hope you're understanding how to find whether the graphs are symmetric about x-axis, symmetric about y-axis, symmetric about origin, symmetric about the line y is equal to x.